In this video, we're looking at what happens when you have different scenarios for determining the linear function. So it can either be graphs, it can be points, be a point and a gradient. One that I have not included is when you are given gradient and intercept, because that is just a matter of m equals 2, c equals -2, and substituting those for mx plus c. So that would be y equals +2 minus 2. That's it. Okay, so I have not looked at that one. What's going to happen is we're going to look at what you need if you've got 2 points on a graph. So I've got that information here. I've just extracted those points on there. And the first thing I'm going to do is determine my gradient. So gradient. So to find the gradient, m equals y2 minus y1 over x2 minus x1. And then I'm going to substitute those in, so I can use so I'm going to use these as x1, y1, okay, and substituting those in. Y2 is -4, 0 over 0, 16. So there is my m equals. Do my calculations. -4 minus 0 is still negative. Minus -16 becomes positive 16. So that is negative. So there's my gradient. So that's the first thing I'm going to do is work out my gradient. Ooh, that was a bit funky. And the second thing I'm going to do is determine where my y-intercept is. So how I do that is I substitute one pair of these points in. This is your gradient point method, essentially. You substitute your gradient. So we're going to substitute m equals -1/4, and pair, does not matter which one, 0, smaller number, smaller numbers, into y equals mx plus c. Y in this case is -4, m is -1/4, x is times 0, c, we do not know what that is. Substitute, and solve using algebra. So -4 equals 1/4 times 0, which is 0. So plus c. So 0 plus c. I should have noticed that. That is a y-intercept there. Anyway, still good to go through it. So 0 plus c is, you don't, okay, 0 plus c, -4. If I move the 0 over there, it doesn't matter, it's a positive, but I subtract 0, it's still going to be -4, which means that c is -4. If you have a look over here, it certainly is. So doing the second one, again, that'll be your y-intercept. So it doesn't matter, you could use that. So if you have 2 points on a graph, you use one, you find the gradient, and then you use that to find the y-intercept. Now sometimes it's been given to you on your graph, and you could do that by inspection, or you can also do that using substitution. So up here, you need to fill in what you would need to identify and calculate from these pieces of information. Next, we're going to look at 2 points, but no graph when you've been given this. So I've already written in what I need to do for 2 points, no graph. 1, 4, 3, 6 is those coordinates from the other pair. The first thing I'm going to do is I'm going to find my gradient. So, and I do that by using rise over run, or the difference between y and the y values and the x values. If you have a look here, this is, we just call this x1, y1, x2, y2, and substitute those into my gradient formula. M equals y2 minus y1 over x2 minus x1, and substituting those in. So what we can see here is that this is the 2 values, so 6 minus 4, so I should be putting them in brackets. Tricky to do it post. And 3, ooh, what am I doing? So if we can hide that, there we go. 3 minus 1. Some nice whole whole integers, positive integers. 6 minus 4 is 2, 3 minus 1 is 2. My gradient, therefore, is a positive 1. Now that I have a gradient, I can find my y-intercept. Oh yeah, intercept. And I'm going to do that by substituting m equals 1 and any of these coordinates, 1, 4 into y equals mx. Y in this case is 4, m is 1, times x is 1 plus c. 4 equals 1 plus, oh, I should get an orange colour here to match what I do on the boards in class. What number plus c gives us 4? So using your star bridge, so the inverse of adding 1 is subtracting 1, and c equals 3. I just realised before I didn't, with this one, 3. Sum m equals 1 and c equals 3. So that would be y equals 1 x plus 3, or we write y equals x plus 3. Now I just realized that I've only just done the intercept and the gradient on this last question, so then to finish that off you would also have, again as well, determining the equation. You actually need to write the equation. Whoops. So here we're writing the equation. M equals 1/4, c equals -4, and your equation is going to be y equals mx, so -1/4 x, it's not plus because there's a negative here, 4. That is your equation for a line that passes through these 2 points. These ones, sorry, not these ones, these 2 points. Alright, okay, so now what we're going to go and do, you'll see that these two are very similar. You need to identify if there's a y-intercept given to you, and then you need to calculate always the gradient for both of these, and this one here you need to work out your y-intercept. That is why they call it the gradient point intercept method, because you work out your gradient first, then you work out the y-intercept, which is a point, and then you substitute those values into your y equals mx plus c. Right, last one, 1 point, and the gradient. So if the gradient's been given to you, half the work is done. You just have a point to substitute in to find the equation. So let's do that. So here we go, we've got gradient and 1 point. So if the gradient's been found, you do not have to do the whole this bit, finding m, because it's been given to you. Here it is, and it's all beautiful glory. M equals, making sure, m equals 5. So you've already got that. This is your m value. So 1, gradient is m equals 5. Second thing you're going to do then is use, essentially what you're doing is just skipping this step and going to the y-intercept and then the equation. So we need to work out the y-intercept. Sub m equals 5, and you don't have a choice now of points. You just got to get what you're given. So 5, 6 into y equals, oh, that's too many equals, control them. Mx plus c. Sorry. Okay, and then we're going to substitute all those values in. So 6, 5, bracket 5 plus c. So 6 equals 25 plus c. What number do I add to 25 to get 6? So I'm going to take that number and move it. And that is going to be, oh, didn't change colour. So that is going to be 6 minus 25 is negative 19, and that's going to be our c value. So now that we've got our gradient and our y-intercept, we're now going to find our equation. 3 equation. So we substitute m equals 5 and c equals negative 19. And then we into y equals m is 5, x is the same, no plus 19. So weird things on my screen. So that is the equation for a line that has a gradient of 5 and passes through 0.56. So that is what you need to know. Alright, so if you have a look up here, I want you to consider what you might need to do for each. So what's been given to you when you have a look at these different scenarios, and what might you need to calculate. So you might have something that's by inspection, so by identifying, and then something by calculation, so either calculating your gradient or using algebra to solve for C. Okay, stay awesome everyone. Good luck.